Welcome back, everybody. Yesterday you learned a lot about proportions and solving them and ratios. Today we're going to apply some ratios and proportions to similar figures. I'm going to teach you what similar figures are and then how to identify specifically similar triangles using some shortcuts, angle, angle, side, 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 and side, angle, side. So first, what is a similar polygon? They have the same shape, which means all the corresponding angles are congruent, but they're not necessarily the same size. All the sides have to be in proportion. The proportion of the sides is called the similarity factor, sometimes called the similarity ratio. Let me give you an example. Now for this figure, we have two quadrilaterals, A, B, C, D, W, X, Y, Z. Notice that the corresponding angles A, W, B and X, C and Y, D and Z are all congruent to each other. In addition, the corresponding sides all have the same ratio. If you look at it and you put the corresponding sides together to make a ratio, you'll notice that they're all proportional. They're all equal to 3/1. Now you could also do it the other way around and put 1/3. This is showing it from A, B, C, D to W, X, Y, Z. Now, to write the similarity, you would use this symbol here. It's almost like a congruent symbol, but it doesn't have the equal on it, because these two shapes are not equal to each other. They're not totally congruent. They're just similar shapes, not the same size. Let me show you some shortcuts for how to show triangles are congruent. Now, if it's not a figure that's a triangle, you would have to go through all the corresponding angles and all the corresponding sides, but for triangles there are some shortcuts. First, we know the angle-angle similarity postulate. It says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So for example, on this one we have ABC and XYZ. Notice angle A and angle X are congruent. That means they're corresponding. Angle B and angle Y are congruent. That leaves us with C and Z must also be corresponding and congruent. So what we know by angle-angle similarity postulate is that triangle ABC would have to be similar to triangle XYZ because of angle-angle similarity. Every time you have to have two pairs of congruent angles to use angle-angle similarity. Now let's say you don't have two pairs of congruent angles, maybe you only have one pair of congruent angles. Something else that you can use is called side-angle-side similarity theorem. So for this one, the angle has to be between the two sides. So we have the lengths of two pairs of sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles have to be similar. So if you look on this one, we see that the corresponding sides DE and TU, they have the same ratio as the corresponding sides EF and UW. Notice 5/2.5 is the same as 2/1. In addition, the angle between those two sides, the included angle, E and U, they're both right angles, making them congruent as well. So since we have two pairs of corresponding sides that are in the same proportion and the included angle is congruent, we can say these triangles are similar by side angle side. Make sure you put your points in the correct order to show what's corresponding when you're writing your similarity statement. Next, if you don't have any angles that you know are congruent, you could always still use side-side-side similarity. So this says that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So for this one, you have to have all three pairs of sides are proportional. Make sure you're staying in the same order and consistent. So for example, I put triangle GHI in the numerator on all these fractions, and then I put triangle MNL in the denominator on all these fractions. you have to make sure that you're consistent. Notice that for all of them. For example, 3 over 9, 1 over 3, 4 over 12, they all can reduce to 1/3. So what that means is that these two triangles are similar by side-side-side similarity. Let's go through a few examples of these. Determine if the triangles are similar, and if so, write a similarity statement. Find the scale factor if possible, and justify your answer. Whenever it says justify your answer, make sure you're giving one of the theorems that we just talked about. So for this one, when we just start out, we see angle M and angle L are congruent to one another. So that's one angle that we know is congruent. That's good. But we don't know anything about the sides. So let's keep looking at the angles. Now, it doesn't look like J and P are congruent, but if I find the missing angle, angle K, by using the fact that all the angles have to add up to 180, I find that angle K is equal to 75 degrees. Now, based on the angle K being 75 degrees, I can say angle K is congruent to angle P, which gives me another pair of corresponding congruent angles. Since I have two pairs of corresponding congruent angles, I can say the triangles are similar by angle-angle similarity. Again, make sure you put the letters in order of what's corresponding when you're writing your similarity statement. This one I don't have enough information to find the scale factor since I don't know anything about the sides. Next I come to this one. This one I notice that I have two pairs of parallel lines. One pair of parallel lines. I know parallel lines will always give me congruent angles. Let's look at this as my transversal first. Using XT as my transversal, I can tell that angle X and angle T have to be congruent because they're alternate interior angles. Now I could also look at the other transversal to show R and W have to be congruent. Or another option would be to look at angle RSX and WST because they're vertical angles. But I only need two pairs of angles, so once I have two pairs of angles by alternate interior angles postulate, I can say these triangles are similar by angle-angle similarity. Next, let's look at this one. Again, I see angle C is congruent to angle D right away because they're both congruent, they're both right angles. That's one pair of angles. Now I need to have another pair to say that they're similar. So I know B and F are definitely not the same because one is 44 and one is 47. But this is a case where I'd want to find the missing angle to see if that angle pairs up with angle F. When I find angle A, I know that the acute angles of a right triangle have to be complementary, so I'll do 90 minus 44. I get 46 degrees for angle A. Angle A and angle F are not the same. Since I only have one pair of congruent angles, these triangles are not similar. They're totally different shapes. They have totally different angles, which means they're not the same shape. Alright, next I have another one where I have some parallel lines. I have one pair of parallel lines, PQ and JK. Let's look at this transversal first. Notice that angle K and angle PQL are corresponding angles. Since they are formed by parallel lines, I know they have to be congruent. So there's one pair of angles. Now let's look at the other transversal. Oops. I could do the same thing. Angle J is congruent to angle QPL. Now, I wanted to show you another option though. You could also say that angle L is congruent to itself since these two triangles are overlapping. Angle L has to be congruent to itself by the reflexive property. So either way you do it, you'll be able to get two pairs of congruent angles that are corresponding. So I'll have 1, 2 that I listed here. So I know that these are congruent by angle similarity. Again, not enough information to find the similarity ratio. Alright, let's look at this one next. Now I have two triangles that are overlapping again. So I know I can automatically say that the angle that's shared by both is a congruent angle. But I don't have enough information to show that any other angles are congruent right now. Unless I knew the lines are parallel, that would help, but it doesn't tell me that they're parallel, so I'll have to do something with these sides. Now remember, you have to be consistent which triangle you put in the numerator, which triangle is going to go in the denominator. Now I know that the smaller side has to match up with the smaller side on the other triangle. So that's why I matched up 8 and 12, and then 10 and 15 are going to go together because they're both the bigger side. So I'm going to see, is 8 over 12 the same ratio as 10 over 15? Let's see by reducing it. 8 over 12, 8 and 12 are both divisible by 4, you get 2 over 3. Similarly, 10 and 15 are both divisible by 5, you get, again, 2 over 3. Since both pairs of sides reduce to 2 over 3, the same ratio, we know that they're both proportional to each other. So I have two pairs of sides that are proportional, and I have one angle pair that is congruent to each other. So since that angle is between the pair of sides, I can use that these triangles are similar by side angle side similarity. Alright, this next one, they actually gave me three sides. I went ahead and matched up the smallest side on one triangle with the smallest side on the other triangle, and the largest sides I matched up, and I put them all into fractions. Now, in order to see if they're all the same proportion, I'll have to reduce each one. So let's say 6 over 15, you could do it on your calculator. This one you could probably do without your calculator. They're both divisible by 3. You get 2 over 5. You can do the same thing for every single one, and you'll notice every single fraction reduces to 2 over 5. Since they're all the same proportion, I can say these are similar by side similarity. Now this one actually has another option. Since these triangles share the vertex R, I could say PRQ is congruent to SRT because they're vertical angles, and I could actually use side angle side for this one as well. So depending on which pieces you could give a different reason. Okay, in this one I do have enough information for this similarity factor would be 2 over 5, as I already found. Alright, this is the last one for this type. Match up the sides that go together. Remember, the largest side goes with the largest side, the smallest side goes with the smallest side, and then we're going to reduce and see if they all have the same ratio. For example, 16 over 12, they're both divisible by 4. I get 4 over 3. I can do the same thing for every other fraction, and I see that they all reduce to the same ratio, 4 over 3, so they're all proportional, and that's the similarity factor. So I can say that these triangles are similar by side similarity. Okay, so next we're going to look at this on a coordinate plane. So, this first one, we want to verify the dilation as a similarity transformation. I already graphed it, and I can automatically see right away that they have two angles that are congruent because they're both right angles. They're formed by a vertical and a horizontal line. So I can automatically say angle Z is congruent to angle C since they're both right angles. Next, I'm going to see if I have any other angles. Since I don't, I'm going to have to use either side angle side or side side side. I think since I already have one angle, I'm going to probably try to go for side angle side to show that these are similar. So I'm going to first start, I'm going to decide to put triangle ABC in the numerator, XYZ in the denominator, and I'll start with sides AC and XZ. AC has a length of 9, it's easy to find since it's horizontal line. XZ has a length of 6. If I reduce, I get 3 over 2. Now, I'm also going to use the vertical line since those will be easiest to find the lengths of. BC has a length of 6. YZ has a length of 4. This is also a ratio of 3 over 2. Since I have two pairs of sides that are in the same proportion and the angle between those sides is congruent, I can say the triangles are similar by side angle side similarity. Next, for the other one, I'm going to start by drawing the shapes, and you'll notice I have some different color triangles on here. That's to go ahead and help me find the lengths of the sides. So I already have some of this drawn on here. I can't find any of the angles unless I had known that one of them were a right angle, but it's not evident off the bat, like there's no vertical and horizontal line. So I'm probably not going to choose option 1, angle. Since I don't have any angles, I'm probably not going to choose side angle side either, since that requires an angle. So I'm going to go ahead and try to do option 3, where I find all 3 side lengths for both triangles and see if they all have the same proportion. Now, if one of them doesn't, I can stop and say they're not similar. I'm going to put triangle ABC in the numerator, DFG in the denominator. First, I'm going to start with AB and FD. I drew my little pink triangles in here, as you can see, and then I redrew them so that I can work with them over here. To find the length of AB, I see that the horizontal side is 2 and the vertical side is also 2. That's helpful. It's a 45, 45, 90. So I know AB is going to be 2 square root of 2. Similarly, FD is going to be 4 square root of 2, since it's also a 45, 45, 90. So in order to find that ratio, I'm going to do 2 square root of 2 over 4 square root of 2 and reduce it. This can reduce to 1/2. Next, let's look at AC and DG. I'm using the green triangles now. Remember, to find the length of a slanted side, I draw a right triangle using that as the hypotenuse. For AC, I'm going to need to do 1 squared plus 3 squared and then square root it. So I get the square root of 10. For DG, I need to do 2 squared plus 6 squared. I get square root of 40. Now this can reduce because if I do a factor tree on 40, I find a pair of factors, 2 times 2. That means 2 can come out, and then 2 times 5 has to stay under the radical, so square root 40 is the same as 2 square root 10. So for this ratio, I'm going to do the numerator over the denominator. Now on this one, square root 10 and square root 10 can cancel out, so again I'm left with 1/2. So far I have the same proportion for these pair of sides. These sides are proportional. Now let's check the last pair. Now I'm using the yellow or the orange triangles to find BC and FG. I have them drawn here. Now I already did this right triangle 1, 3 as the legs, and I already found it's square root of 10. BC and AC are the same length. Similarly, FG and DG are going to be the same length. Notice the right triangle turns out the same. It has the legs 2 and 6. So I know that FG is going to be square root of 40 or 2 square root of 10. So obviously, since AC, BC, and then DG and FG are the same, when I do this ratio, square root 10 over 2 square root 10, I'm going to get the same proportion, 1/2. Since all 3 sides have the same proportion of 1/2, I can say these triangles are similar by side, side, side similarity. Alright, finally, I want you to try to draw your own triangle that's similar to this one shown, and explain how do you know it's similar in 1 to 2 complete sentences. Tomorrow we're going to practice finding missing sides in similar triangles. I look forward to seeing you then. Bye!